Alright, 138 and 144 were asked for homework. I'm going to solve a couple of those. I won't do every part of it, but they're important because they do deal with function notation. So A says solve g of h of 4. And it's important to know what g and h represent. So your g of x is equal to the square root of 2x plus 4. And h of x is equal to 1/2 x squared minus 2. Alright? Now there's a couple ways you approach it. I'm going to do A a certain way, and then we'll look at B, and you can kind of decide on the method you prefer. So let's start here. H of 4. We're only going to be dealing with this function. So h of 4, we can go ahead and substitute h of 4 as our input. Our input will be 4. We'll replace x with that. Minus 2. Work this out. 4 squared 16 times 1/2. That's 8. 8 minus 2, which is 6. So now the h of 4 is 6. Alright? That's good. That's the first part of this. Now the next part of this is to take 6 and evaluate it for g. So now, since we know h of 4 is 6, we can do g of 6. We do the same process, run 6 through now as our input. Square root of 12 plus 4, square root of 16, which equals this 4. So g of 6 is equal to 4. Alright, so that's our output there. So now if we were to write out the whole thing, it would be g, of h of 4 is equal to 4. Okay, so you're using your input 4 here. Your input 4 gives you a 6, and then we use our input 6, plug it back in to get another 4. So our final answer is like that. Now that's one way to approach it. We can also approach this a different way. Some of you might prefer doing it this method. So let's look at B. So B asks you to evaluate h of g of -1. Well, this h of g, we could, let me rewrite the functions again, g of x equals square root 2x plus 4, and h of x is equal to 1/2 x squared minus 2. So there's another way you can approach this. We could approach it just by doing this and then evaluate it at the end. So we could do h of g of x, which if we compose this, we'd have 1/2 parentheses squared minus 2, and then the g is going to drop inside 2x plus 4, square root of 2x plus 4 will go inside. Now right now it looks a lot more complicated when you do it this way, but there's a purpose in doing it this way. 1/2, square root and the square cancel, so you're left with 2x plus 4 minus 2. We take the 1/2, we distribute. This will equal 1x plus 2 minus 2. These cancel, and you are left with h of g of x is equal to just x. Now, a lot more work than what we did earlier, but there's a reason for it. This allows you to solve for any value of x. So if we were to take h of g of any number, our output would just be whatever that number is. So now we take this idea and we apply it to B. H of g of -1 is equal to just x. And if my x is -1, my answer is just -1. So it gives you one rule for solving it. Okay, so that's kind of a general rule for it versus just plugging in the number. Also, part E talks about the inverse a little bit. Part D and E. says D, did you get the same output as your original input? Yes. And the reason is those two functions are actually inverses of each other, and we'll explore more of that later. Now let's go 41. So for 41, let's look at we do A and maybe D. Okay, so A is first we have f of x is equal to x squared plus 2x, and g of x is equal to the square root of x plus 1. So A asks us to evaluate g of x minus 2. Alright, here's your input, x minus 2. So we're going to substitute x minus 2 in for x. So we will get the square root of parentheses plus 1, and we're going to put x minus 2 right in there. This is replacing your x. We go ahead and simplify. Negative 2 plus 1 be the square root of x minus 1. G of x minus 2 is equal to x minus 1. Okay. Let's look at D. D asks us for f of 1, which is a problem like this in class. So remember, we're dealing with function f, so wherever you see an x, go ahead and write parentheses. D squared plus 2 times parentheses. And I'm going to work this from the inside out. And then we have, you know what? Let's approach this from a different angle. Instead, let's evaluate this first, since we're evaluating for a number. So our input's 1, so it'll be parentheses squared plus 2 times parentheses. 1's your input, so we get 1 plus 2, which equals 3. So f of 1 is equal to 3. Now let's translate that. Now we need to find f of 3. So now we'll go ahead and plug this in. Parentheses squared plus 2 times parentheses. Same process, except now 3 is your input. So we get 9 plus 6, and that's going to equal 15. So f of 1 is equal to 15. The last one I'll do is f. So f seems to be a bit tricky. Alright, so f is asking us for g of f of x. Alright, so g, I'm going to start with g on the outside, so we have square root. Instead of putting an x, put parentheses plus 1. Now my f's on the inside. So we're going to do x squared plus 2x goes in the middle. And fortunately we can't simplify this too much, but we can write this out without the parentheses. There it is. Now, there's one, I could take the square root of this by actually factoring this, so you should be able to see x plus 1 squared. So the nice thing about this, the square and the square root cancel. That's the factored form. This just comes from x plus 1 times x plus 1. So now we're left with just x plus 1. Now the answer actually says x plus 1 with absolute value. Now what that means is that x value, this number expression when you're done with it, must be positive. Why is that? Well, if you look at it, originally it's all under the square root. So for it to be a real number, it's got to be positive. If it's negative, you'll get a negative number, and you'll have an imaginary solution. Alright, I hope that helps with 41. You can use these questions to help you answer the other ones.